Okay, so example 5 is going to take into account the relationship between three things, and you might remember this from yourself. So relationship between displacement, velocity and acceleration. So what we've got to remember is that velocity is the rate of change of displacement and acceleration is the rate of change of velocity. So what does that tell us? Well, that's like saying that velocity is the gradient of the displacement and the acceleration is the gradient of the velocity. So if I want to go down, if I've got displacement and I want to find out velocity, or I've got velocity and I want to find out acceleration, we need to find the gradients, which means we are going to differentiate the functions. And vice versa, if we're going to go back up this way, we are going to integrate the functions. Okay, so these next 3 lessons we're all going to focus on that idea that's moved between them. We can either differentiate or integrate. So let's start off with example 5, right? And part A asks us to find an expression for the velocity, right? And it gives us the acceleration in the question. So that means that to get the velocity, we are going to integrate with respect to time. It's always respect to time. So time is always the variable. So anytime I'm differentiating, it's with respect to time. And anytime I'm integrating, it's also with respect to time. So if I've got the integral of acceleration and it tells us the acceleration is cos 2 pi t, there should really be a bracket in there just to make it clear what's going on. This is with respect to dt. So I just need to integrate that term. I'm integrating a cos, so hopefully we remember from our year 13 differentiation work that this goes to a sine. The inside will remain unchanged and we've got to divide by the coefficient in front of the t. So this is 1 over 2 pi. The other thing, because we've just integrated, unfortunately, we're going to have a plus c term on the end there. Okay. So then what we're going to do with that is we are going to use the information in the question, which is that at t equals 0, the velocity is 1 over 2 pi, and that's going to help us find out what c is going to be. So if I've got v equals that, I can put 1 over 2 pi from the question in there. This is equal to 1 over 2 pi sine 2 pi times 0 plus c. And this is going to be the sine of 0, and sine of 0 is 0. So that means that we can take that out. 1 over 2 pi equals 0 plus c, so it's just c. What does that tell us? Well, that's going to give us our final answer that v is 1 over 2 pi sine 2 pi t plus 1 over 2 pi on the end. Okay, so that's integrating the acceleration to find out what the velocity is. Part B asks us for the maximum speed, right? Notice it doesn't ask us for the maximum velocity, and the difference between speed and velocity is that speed doesn't take into account of the direction. So actually, it could either be we need to compare two things here. We need to compare the maximum positive velocity and the minimum negative velocity. Right, what do I mean by that? Well, if we had a velocity at one place was say 10 meters a second and a velocity at another place was minus 15 meters per second, then that would mean that the speed, the maximum speed, would actually be 15 meters per second, right? Although it's going in a negative direction, speed doesn't take into account that. So we've got to check that we've got the maximum and positive and the minimum negative velocity. So here the function is a sine function, so hopefully remember from our work on the pure that the sine function is maximised. The maximum possible value it can be is 1, and the minimum possible value that sine can be is minus 1. So we're going to replace the sine term of each of these by 1 and then by minus 1. So if we replace it by 1, we get 1 over 2 pi times 1 plus 1 over 2 pi, and that gives us 2 lots of 1 over 2 pi, so it's 2 over 2 pi, and we can cancel that to 1 over pi. That's for when the value is 1. Let's just check what happens when it's minus 1, when sine, that whole sine term becomes minus 1. Well, what we'll actually get is they'll cancel out and the velocity goes back down to 0. So actually the velocity doesn't become negative at any point because we've substituted in the lowest possible value of sine, which is minus 1, and it's still 0. So it's this function, it always has a positive velocity. So that tells us that the max speed is, of course, from here 1 over pi meters per second. Okay, that's A and that's B, and that just leaves us with part C to do, and part C asks us to find the distance travelled in the first 3 seconds. So to find the distance travelled in the first 3 seconds, well, if we want distance, right, we have to deal with displacement. So the displacement and the distance is going to be the integral of the velocity. So it's the integral of the velocity dt. And because we're looking to find what's going on for the first 3 seconds, we want the full distance travelled between that, we're going to have to go between 3 and 0 as the integrals. That's between the 0 seconds and between 3 seconds. And our expression for velocity is 1 over 2 pi sine 2 pi t plus 1 over 2 pi dt. Now, normally we might need to be a little bit cautious when we're doing an integration like this, in case at any point this became negative and then we'd have the areas under the curve subtracted. Luckily though, from part B, we've already worked out that this function is always positive, so we don't need to worry about what happens when we go under the x-axis. To do this integration, I'm going to start by taking a factor of 1 over 2 pi out to make my life easier. So this is just going to be sine over 2 pi t plus 1 dt, and I'm going to remember to times my answer by 1 over 2 pi at the end, and then I just need to integrate. So again, from my integration work, sine, when we integrate that, is going to go to minus cos, and I've got a factor of 2 pi multiplying the t, so it's going to be minus 1 over 2 pi at the front, cos 2 pi t, and then this 1 is going to integrate to make a t. Then all I have to do is substitute in those two values. So I have to put 3 in and I have to put 0 in. So when I substitute 3 in, we're going to get minus 1 over 2 pi times cos of 6 pi plus 3, and then we need to subtract what happens when we put 0 in. So it's going to be minus 1 over 2 pi cos of 0 plus 0. So let's work that out. Just running out of space here a little bit. 1 over 2 pi, and cos of 6 pi is 1, so this will be minus 1 over 2 pi plus 3, or minus, cos of 0 is 1 as well, so minus 1 over 2 pi. We expand that and collect up the like terms. It's 1 over 2 pi still out the front from the start, and we've got the minus 1 over 2 pi and the minus 1 over 2 pi are going to cancel, so it's times by 3, and we should have a final answer of 3 over 2 pi meters, because we're dealing with displacement. Okay, so it's just a fairly standard integration question from your Year 13 integration.